In this video, we'll learn about C-style strings. C-style strings are about as simple as it gets. They're a sequence of characters stored contiguously in memory. They're implemented as an array of characters, so you can access individual characters using the array subscript syntax that we've already learned. How do you know where the sequence of characters ends? C-style strings use a sentinel value that marks the end of the string. The null character is used, which is equivalent to the integer 0. So, C-style strings are often referred to as zero or null terminated strings. We've been using C-style strings all along in this course. We've used them mainly in our output statements as string literals. Recall that string literals are sequences of characters enclosed in double quotes. These string literals are constant, so we can't change them, just like we can't change integer literals. Even though we don't explicitly provide a null character at the end of the string literal, C++ inserts one for us. That's the way the end of string is handled. Let's see an example of a string literal and how it's stored in memory. Here's a real simple example that shows how C-style strings are stored in memory. In this case, we have a C-style string literal containing the sequence of characters C++ is fun. These characters are stored in a contiguous block of memory that can be accessed as an array. Notice that C++ is fun has exactly 10 characters, but the compiler allocated 11 characters for the array because it needed space for the null character at the end. Literals are great and very useful, but we more often than not need to create string variables. Let's see how we can create C-style string variables. In this example, we're declaring an array and initializing it to Frank, using initializer list syntax as we've been doing with integers and other types. Notice that the C++ compiler will allocate 6 characters for this array, since it needs to terminate the string with the null character. Also notice that the size of the array is fixed, so if I wanted to add a Y to Frank and create Frankie, I couldn't without having some potential problems, since the new string would not be null terminated. You won't get a compiler error or even a warning. In fact, in this case, my name sub 5 is still within the array bounds. Let's see another example. In this example, we are explicitly asking the compiler to allocate 8 characters for the character array. And we're initializing it to Frank. In this case, it will initialize the array with F-R-A-N-K, and the rest of the space will be zeroed out with null characters. In this case, if I wanted to change the character at index 5, which is that first null character, to a lowercase y, it would be just fine, since the string now contains Frankie and is still null terminated. Let's see another example. In this example, we ask the compiler to allocate an array of 8 characters and we don't initialize them. This could be very problematic, because if you use this array as a string, all C-style string functions expect to find a null character. And here there may or may not be one. We really don't know what the data in the array is. Suppose we wanted to display the string now. How do you think this would happen? How do you think C-style strings are displayed? Well, in this case, we start at the first element of the array and we iterate through the array. At every character, we see if it's the null character. If it is, we stop since we reach the end of the string. If it's not, we print the character and then we move to the next character. In this case, we don't know what's going to happen. We might see a null right away, or we might not see a null for a very long time. In the meantime, I'm printing stuff to the screen. Some of the stuff may not even be displayable since some characters are control characters. You might think we can initialize C-style strings using the assignment operator, just like we have with other types, but this won't work. If we try to assign the C-style literal Frank to my name, we get a compiler error because that's not the way C-style strings work. Array names and literals evaluate to their location in memory, so we're effectively assigning one location to another, which is illegal. Think of this as saying assign 10 to 12. It doesn't make sense and the compiler won't allow it. In order to assign one string to another, we need to use a function called string copy that copies the C-style literal F-R-A-N-K to the myname array. There are lots of C-style functions that C++ brings in from the C programming language. Let's see a few of them. The C-string library contains many functions that work with C-style strings. These functions are used to copy, concatenate, compare, search, get the length of a string, and many more. They all rely on one common factor, that the sequence of characters they're working on is terminated with a null character. If you're using C-style strings, you must be very aware of this. For example, suppose you have a C-style string and you want to determine its length. Well, let's say we have Frank. Since no length information is stored with the string, only the characters in the array, the only way to determine the length is to start counting at the first array element, and then increment along until you see the null character. So in the case of Frank, we would look at the F, increment 1, look at the R, 2, the A, 3, the N, 4, the K, 5. Then we see a null character and we stop. Now we know that the length is 5. But if that null character is not there, we keep going and we keep counting. So the result will very likely be incorrect. Even worse, if you're copying one string into another and the string you're copying isn't null terminated, you'll very likely exceed the bounds of the target string and very likely cause a program crash. This all sounds pretty ominous, but in fact, we've been programming in C and C++ using C-style strings for a very long time, and we've gotten pretty good at understanding these issues. But wouldn't it be great if we didn't have to worry about these issues at all? That's where C++ strings come in. We'll talk about them later in this section. Here are a few examples that use the C-style string functions. You typically have a function and you pass into the function the name of the string or the string literal or both. We'll talk about functions in detail shortly, but conceptually they're really easy to understand. For example, if I'm a function and my job is to return the color of a crayon passed to me, then all I need from you is the crayon. So you call me and send me the crayon and I'll return red, green, blue, and so forth. That's the idea, and here it's the same. If you want to know the length of the string, pass in the string to the strlen function and it returns the string's length. Here are just a few examples that copy, concatenate, and compare strings. C++ also has another library called cstdlib that contains functions that convert strings to other types. For example, if I have a string with the digits 1 and 2, I can convert that to the integer 12. Sometimes these are real useful functions. However, all of these functions rely on the same thing. They're all working with null terminated strings. If you're using C-style strings, you have to be very aware of that. Well, that completes this video. In the next video, we'll head over to the IDE and we'll write some examples using C-style strings.